Hello, this is Laura Wobuzovian, your math professor for this semester, and we're going to take a quick look at Project 2. So going into modules on our left-hand side of our computer screen, I'm going to go down until I see StatDisk Help, which we looked at in a previous video, and if you've missed that or if you would like to rewatch it, there is the intro video at the very beginning of that module. Project 1, which we have completed, and then also Project 2. And for Project 2, this is dealing with commute times. And the PDF and the Word document are both listed here, along with where we turn our project in. And again, we're submitting this as a single PDF file. So I'm going to go ahead and look at our StatDisk manual again. And opening this up, which we saw previous videos, I'm going to jump to page 5. And page 5 again is the really nice one that allows us to kind of see all the drop downs at one time. And you'll notice that in Project 2, it's going to be asking about confidence intervals, and you can see that underneath analysis. It says confidence intervals. We also see hypothesis testing, which we'll see too and later on. And then a few other things. And you'll notice too that, like, for example, probability distributions, if you were to click on that, just like with confidence intervals, it opens up another box, and you'll see that there's different types of probability distributions. And then continuing down to the next page, so page 6 in the manual, you'll notice that all the chapters here are listed. What's nice about this is you can click on them and it will lead you right to that page, or you can scroll or type it in at the top. So for some of the problems, specifically the last couple on Project 2, we'll say that we need to find a probability. And so that's going to be using the normal probability distribution. And so clicking on that, it takes me to the page where Chapter 6 starts. And you'll notice that it's broken up so you can kind of see exactly where you need to go, depending on what the question is. But just looking at 6.1, which is asking about finding areas and values with normal distributions. And it talks you through, it tells you exactly what to do. So this is the StatDisk procedure for finding probabilities or z-scores with a normal distribution. So it walks you through, it also gives you like the formula here for z-scores if you don't remember that. And so I'm going to go ahead and pull up our project really quick so we can look at that, which again is in modules, and Project 2 will have its own folder. So Project 2 is on commute times. We're using a little bit different this project. We're actually going to be using one of the data sets. So dataset 31 on StatDisk, it's titled commute times for this project. And it also tells you assume that dataset 31 on commute times is normally distributed. Again, this is an individual project and you want to make sure that everything is typed. Each part needs to be correctly labeled and this needs to be completed in order. The program I'm using is StatDisk. Again, if there's something else you would like to use, definitely reach out and let me know. Projects must be uploaded to Canvas by the due date as a single PDF file. No late projects, so make sure you get an early start on this. And the points for each part are listed, and the total points that can be earned are 45 points. You'll notice that also for this project, we have a lot more screenshots that we're going to have to be taking. So parts 1, 2, 3, 6, 7, 10, and 11 must all have screenshots. So make sure that you do that, just like what we did for Project 1, but this time we have a lot more of them. No points are going to be rewarded for those if you don't use a computer program and instead use a graphing calculator. The screenshots need to be legible and inserted into the project at the correct question number. You also must provide answers and clearly state them. They need to be rounded 3 decimal places unless otherwise stated. And again, we're gaining knowledge. This time we're dealing with a larger data set and we're learning how to use a computer program for statistics. So starting this off, the first one says find the mean and the standard deviation of the commute times. We did this in Project 1. Remember, we went to descriptive statistics and that was what we were able to use. Number 2 says to create a histogram of commute times in minutes. And we did this also in Project 1. So we actually came up with a histogram too, but this time it's asking us, if you see in parentheses, it says use the auto fit option for the class width. Number 3 says to create a normal quantile plot of the commute times in minutes of the 1,000 people in LA. And you'll notice on StatDisk, one of the drop downs, when you drop down from there, you'll see it will say normal quantile plot. And number 4 says, does it appear that the commute times in minutes of 1,000 people in LA are from a population having a normal distribution? Clearly explain and clearly check all 3 requirements. So go back in your section 6.5 notes. And when you look at that, you'll notice that there's 3 things that you need to check. So one of them is going to be the normal quantile plot, which you would have completed in the previous part. One is checking for outliers, make sure you show your work. And the third one is going to be checking to make sure that histogram is roughly bell-shaped, and you have a histogram up above 2 in an earlier part. So make sure you clearly check all 3 requirements, and again, see section 6.5 for help. Part 5 says clearly check and verify the requirements are satisfied in obtaining a confidence interval for the mean commute time of people in LA. Show all work if applicable and clearly explain. So for number 5, what you need to do is go back into your notes and check to make sure the requirements that you have to verify before actually doing the confidence intervals are met. So it says things along the lines of maybe that your sample has to be relatively large, and what does that mean? So again, go back in your notes and look at that. This would be for confidence intervals is going to be chapter 7, so definitely look in your chapter 7 notes. Part 6 says find a 90% confidence interval for the mean commute time, again it says mean there, for the 1,000 people in LA using the t distribution, and interpret your results. This is worth 5 points, and not interpreting your results will cause a decrease in your score for that. Also make sure you state what the answer is, rounding 3 decimal places as it's stated in the earlier part of the project. Then part 7 is identical, but instead of a 90% confidence interval, we're now doing a 95% confidence interval. And again, interpreting. Part 8 says what happens to your confidence interval? So what happened to it? Did it get wider? Did it not get wider, get more condensed? Explain what happened. Part 9 says what is your commute time to get to Mount Sac in minutes? And if you are not local, then you can go ahead and find a random city and just kind of estimate what your commute time would be if you were to live in that city. And that's just 1 point there. Part 10 says using dataset 31, find the probability that the commute times in Los Angeles will be your commute time in part 9 in minutes or longer. Is the value significantly low, significantly high, or not significant? And clearly explain. Whereas number 11 says using dataset 31 on commute times, find the probability that 25 people will have a mean commute time to LA of 50 minutes or longer. Is this value significantly low, significantly high, or not significant? Again, clearly explain. So if you notice, number 10 is just one person, and finding that their commute time will be in part 9 minutes or longer. So what your commute time is or longer. And again, that's just one person, whereas part 11 is dealing with 25 people. Some good examples to look back at your notes for this in chapter 6 would be, we did one on weights of Coca-Cola, where we did one with just a single bottle of Coke, and then one where it was a lot more, like 36 bottles of Coca-Cola. And then another one we also did was dealing with Cobalt, the Chevy Cobalt. So definitely a couple examples to go back and look at. So getting to that data set, we don't have to type in anything. It makes it a little bit nicer this time. So I put some pictures on here. So you're going to go to data sets. There's a drop down to the 14th edition. Click on that, and I put another picture down here. And again, we're going to scroll down to the one that says commute times. So I'm going to go ahead and open up StatDis so we can take a look at that. And again, to see that, you go to data sets, 14th edition, and then scroll down until you find the correct data set that we need. So right now I have a different data set uploaded into StatDis, so this is not the correct data set. This is a completely different data set, but just something to kind of look at. And I'm going to go ahead and bounce back to what we were looking at in terms of finding our probabilities, which is like the last 2 problems that we had on the project. And so it says to go to analysis, go to the probability distributions, and go to normal distributions. At the beginning of the project, it did say that assume that this is normally distributed. So if you go to analysis, the drop down, probability distributions, and you'll notice that the normal distribution is what you would select. From here, you need to enter your z-value, and if you don't remember how to do that, it did actually say that in the manual. So if you go back and look at that, we have the formula here. It would be your commute time minus the mean divided by the standard deviation that we calculated earlier. So you either are going to put in your z-value, that allows you to find a probability or an area, or you know the area or the probability, and that's going to tell you the time. So one or the other. So for number 10 and number 11 on the project, you're actually needing to calculate the z-values. Careful with number 11 on your project because it was dealing with 25 people, and that does change our standard deviation. So make sure to look back at your notes. Once you have your z-value written in, you hit evaluate, and you go ahead and get that probability that we would have. And so again, we also saw that there was some stuff on 6.5 in one of the problems. And so going ahead and looking at that too, it's going to talk about normal quantile plots and also checking for normality. So going ahead and doing those too. But definitely, if you have any questions about our project, accessing the data, or anything else on project 2, which is on commute times, definitely reach out via email or Canvas inbox and let me know what those questions are. Good luck.